let's take a look at balancing chemical equations.
So let's look at this chemical equation. We can look at it and be like, all right, well, aluminum plus nitrogen equals aluminum nitride. But wait a second, where did those two come from and what do they mean? So this is what you're gonna be given. So there's 2 nitrogen here and 1 aluminum, right? But there's 1 aluminum and 1 nitrogen here. So what the heck do you do? The law of conservation of mass doesn't allow for this. So what you gotta do? All right, well, let's start out. There's 2 nitrogens here, right? So that means that there has to be 2 nitrogens on this side. So let's put a 2 here, because now there's 2 nitrogens and 2 nitrogens. So that's fine. But now there's 2 aluminums. So what can you do to solve that? Oh my god, put a 2 over there. Because now there's 2 aluminums and 2 aluminums, 2 nitrogens, and 2 nitrogens here. And then this is a 1, but you don't write that because if you want to be a cool chemist rather than a nerdy chemist, there you go. So let's look at this double replacement reaction. So first off, we have a polyatomic. Polyatomic here is sulfate on both sides, and because it's the same on both sides, we're going to count that as one whole unit. We're not going to be like, oh, there's 1 sulfur and 4 oxygen. Oh my god. No, it's just sulfate together as 1. So now that we know that, so let's start out with sodium. I was about to call it nah. So we see that there's 2 sodium on this side, right? So, but there's only 1 on this side. So let's start out by putting a 2 over here, because now the sodiums are balanced because there's 2. Remember, the subscripts count and the coefficients count. So now that there's 2 sodium, that also means there's 2 chlorines. So with that, there's only 1 chlorine over here. So we need to make that a 2 as well, because the chlorines need to be balanced. Now, we can see that the hydrogen, there are already 2 hydrogens over here. So that's fine. And then the sulfates, there's only 1 of those too. I know it has a 4, but that's 1 unit. Count this as 1 unit because it is sulfate, not 1 sulfur 4 oxygen for our purposes. So now, everything's balanced. So it's just 2, none, none, 2. Well, it's not really none. These are 1s, but don't write the nones. Remember, we want to be cool chemists, not nerdy chemists. Okay, now let's look at this one. This one's a little more intricate. So we can start out, I'm going to tell you this right now. If you see an O2, leave it for last, because it is most likely going to be the biggest number, and if you start messing with that first, you're going to get annoyed. So let's look at the oxygen over here. So we see how there's 1 oxygen and 2 oxygens. So there's an odd amount of oxygens over here, but a 2 here. So this is going to be even no matter what, because whatever you times that by is going to be an even number. So looking at this has to be at least a 2, right, to make this an even number. But the thing is, if you make it a 2, then the hydrogen, say we do make this a 2, then the hydrogen is going to be 4, but there's 6. So we need this to be a multiple of 6 in order to make that work. So it has to be at least 3, right, to make hydrogen 6, because if we made this 3, then the hydrogens would work out, because there's 6 on both sides. But the thing is, if this is an odd number, this oxygen right here, then there's not going to be an even number. So we can't make it 4, because that's not a multiple of 6. So what is a multiple of 6? Well, multiple of 6 is 12. So 6 times 2 is 12. So now, looking at that, it's an even number, so the oxygens will be okay in the future, and the hydrogen work out. Because this is a 12, this has to be a 2, right? So that the hydrogens are 12 on both sides. So now you can look at the carbon, because you just put a 2 here. Remember, you follow what you're doing. So now you have 12 carbons. So with those 12 carbons, there's only 1 carbon over here. So believe it or not, this is a 12. I know it's a big number, wow. But because there's 12 carbons over here, it's gotta be 12. So now, follow it, there's only 1 more empty space. So now, when you look at that, there's 24 oxygens. But, wait, there's more. There's also the 6 oxygen over there. So there's actually 30 oxygens. There's 30 oxygens because we have the 12 times the 2, which is 24 oxygens in there. And then there's the 6. So 24 plus 6 is 30. So we need 30 oxygens over here. So, but we have a 2. So we're not going to write 30 oxygen 2. That's weird. That wouldn't make sense. So we write 15. Because 15 times 2 is 30. So now let's go back and check our work. All right. There's 12 carbons, 12 carbons. 12 hydrogen, 12 hydrogen. 30 oxygen, 24 plus 6, 30 oxygen. And then, yeah, that's it. So these, like, don't be scared of big numbers. But the thing is, if you get all big numbers that can be divided by the same number, then divide them by that number. Or recheck your work because you did something wrong. But it's okay. We all make mistakes. So I wish you guys the best of luck with balancing chemical equations. They're really fun once you get into them. So good luck with chemistry.